Ultimately, for these three functions, they're gonna ask us questions about the vertex. So the first thing you wanna do is find the vertex of each of the three functions. In the first one, they give us the function in table form. And so what we're gonna do is just plot the points to create the graph. If I do plot all of the points in the table, and you know ahead of time that this is a parabola, when you plot these two, they're across from each other, and you plot these two and they're across from each other, but they're closer together. So you can start to see that the parabola, there's no way it could open up and go through those four. It's gonna have to open down. And then if you find the center of them, if this is back at 8 and this is back forward at 4, there's that invisible middle line that's happening. And so if I find the dead center of these two, I'm right here. Same with these two orange dots that are straight across from each other. Right there is the middle, which is happening at -2. So then when I go plot the point -2, 5, I realize that's the vertex because there's that imaginary line that's going through here. Now they also happen to give us 7, -22, which is not that interesting because it didn't give me one directly across from it, but of course there is. Okay, so as soon as you get a couple of points directly across from each other, you want to go in to find the middle, and you know your vertex is on that center line. So this one, my vertex is -2, 5. Okay, function 2, there's just a picture of the graph. So this one's just quick. You're like, oh, where's the vertex? It's right there. Happens to be right for up 3, and I've got my vertex for my second function. The third function, you have the equation of the parabola. So to find the vertex, you want to use the equation, our formula. The x-coordinate for a parabola is -b/2a. So my b there is -8, and my a is -2, so I want to substitute those in for a and b. When I make those substitutions, again, b is -8 and a is -2, I end up with +8 divided by -4, and that's -2. Now I'm going to take that x value, plug it back into the original function to find the y coordinate. So let's go in and plug in -2 for every x. And when I simplify, I end up getting 19. So when I plug in -2, I got out 19. So the vertex of this third one is -2, 19. So here I'm just summarizing what we just found. Function 1, we found the vertex to be -2, 5. Function 2, we found the vertex to be 4, 3. And function 3, we found the vertex to be at -2, 19. I want to point out for all three of these vertices are at a maximum. This is a -2, so I know this one is opening down. So when it comes to the question being asked, knowing ahead of time that all of these vertices are maximums, that's why it's saying maximum value. Which function has the larger maximum value and what is the larger maximum value? The word maximum is not referring to a big number. I could say the smallest maximum value. It's saying maximum because these are the top of a hill. And so we are looking for maximum value is the y coordinate of the vertex. So if we compare all of the y coordinates of these vertices, this one is 5, this one is 3, and this one is 19. The word larger, any number that's further to the right on the number line is a bigger number. So the larger, so furthest number to the right on the number line, maximum value, y-coordinate of my vertices, that is this one. 5, 3, 19. 19 is the larger one. So that happens to be function 3. And what is the larger maximum value? It is 19. So one more time, if you had some functions and all of the parabolas instead were opening up, then it might say something like, which function has the larger minimum value? Minimum value would be referring to the minimums, so my vertices, and then the value is the y-coordinate of the function. And then if it said larger, you'd be looking for the bigger one. Or if it said smallest minimum value, then you'd be looking at the y-coordinates of the minimums and looking for the smallest of those numbers.